all of you. In this small segment, we will be discussing what is called as enzyme inhibition. Now we have already seen that enzymes are capable of catalyzing a vast variety of reactions and they are extremely specific in their nature, which means that a given enzyme is able to catalyze either a particular substrate or a particular group of substrates or a particular stereoisomer. Now this can be taken advantage of by introducing a molecule which is called as the enzyme inhibitor, which starts competing with the substrate and starts binding with the enzyme. So the molecule that competes with the substrate, the molecule which competes with the substrate and brings down the activity of the enzyme is called an enzyme inhibitor, and this action is what is called enzyme inhibition. Inhibition literally means restriction. So therefore the enzyme is not able to activate itself, or at least become fully active because of the presence of the enzyme inhibitor. This inhibition to the complete action of the enzyme can happen in two ways. In other words, there are two types of enzyme inhibitors. One, competitive enzyme inhibition. The other is called non-competitive enzyme inhibition. We already know that in any enzyme catalyzed mechanism, there is the enzyme and there is the substrate. And the enzyme and the substrate form reversibly the enzyme substrate complex, which will break up to give the product and the enzyme. Now suppose I introduce an inhibitor. Now in this case, the inhibitor is a molecule which is structurally similar to the substrate, which means that instead of the substrate binding to the active site, the inhibitor molecule will go and sit on the active site, will bind to the active site, and therefore inhibitor will start competing for the active site of the enzyme, and you are going to have a new complex formed which is called as the enzyme inhibitor complex. So along with the enzyme substrate complex, you can also have the formation of the enzyme inhibitor complex. Suppose there are say 100 active sites in 100 different enzyme molecules. Imagine I have introduced an inhibitor molecule which is very similar to the substrate. What can happen is this, that immediately as soon as I introduce the inhibitor and the substrate together, there is a competition between the two to go and get hooked to the active site. Because they are structurally similar, the enzyme cannot discriminate, it cannot differentiate between who is the substrate or what is the substrate and what is the inhibitor. And therefore the inhibitors will start blocking the active site and thereby bring down the enzyme activity. A typical example is thiourea, which brings down the activity of urease. We have already seen this, that urease is a absolutely specific enzyme which catalyzes the hydrolysis of urea. Now thiourea is the sulfur analog of urea, where the oxygen of urea has been replaced by sulfur. Other than that, there is absolutely no change. And therefore structurally thiourea and urea are very similar, and therefore both can fit into the active site of the enzyme urease. Here the rate is decreasing because a new complex is getting formed between the enzyme and the inhibitor. On the contrary, in case of non-competitive inhibition, the substrate and the enzyme, of course, if they come together, will form the enzyme substrate complex, which can degenerate into the product. But in this example, the inhibitor is not structurally similar to the substrate, which means that the inhibitor will not go and bind directly to that particular active site of the enzyme. Then what does the enzyme do? What does the inhibitor do? The inhibitor goes and binds to some other part of the enzyme. It will not bind directly to the active site, but it will rather bind to some other part of the enzyme, or it will bind to some other part of the enzyme substrate complex. So therefore there are two paths open to the inhibitor. One, it can get itself attached to some other part which is not the active site to form what can be called as the enzyme inhibitor complex. So because of this, what happens? The enzyme is now no longer free to get bound to the substrate, and therefore the concentration of the enzyme substrate complex that should have been formed will decrease. Suppose the substrate will bind to the enzyme and forms the enzyme substrate complex, but even before it forms the product, the enzyme substrate complex can bind to the inhibitor and form a new complex, which is the enzyme substrate inhibitor complex. Now this also brings about certain conformational changes in the complex, and therefore the conversion to the product will be affected. Hence, the non-competitive inhibitor will bring down the activity of the enzyme not by directly blocking the active site, but rather by binding to some other part of either the enzyme or the enzyme substrate complex. In either case, the concentration of the enzyme substrate complex will decrease. This is what is called as non-competitive inhibition. There is a third category called uncompetitive inhibition, which I just orally mentioned. In this uncompetitive inhibition, the inhibitor molecule will only bind to the enzyme substrate complex, but not directly to the enzyme. Even in that eventuality, the concentration of the enzyme substrate complex will decrease, which overall decreases the rate of enzyme catalysis. Thus, an inhibitor molecule is able to, one way or the other, either by being structurally similar to the substrate or by being able to attach itself to another part of the enzyme molecule or to another part of the enzyme substrate complex, bring down the concentration of this intermediate. Once the concentration of this enzyme substrate complex comes down, naturally the amount of product will also come down. Now, why is this enzyme inhibition very important? Please understand that enzymes are required not only say for the human body, but also for the pathogens which bring about infections or diseases in the human body, or for that matter any living system. And therefore, if it is possible for us to design a molecule which is able to bring down the enzyme activity of a particular pathogen responsible for a particular reaction, then we will be making that pathogen useless. In fact, we will be able to correct the action of that particular pathogen. And therefore, in drug designing, we are looking at ways of making molecules which are capable of inhibiting the action of enzymes which cause problems to the living system. And therefore, a good drug design will take into account whether it is possible to design a molecule which can inhibit the enzyme action either by competitive or non-competitive or probably even by uncompetitive enzyme inhibition. This, I suppose, is the importance of what is called enzyme inhibition.